Alright, this is a continuation of the previous video on hyperbolas. One of the goals for the video today is to try to figure out how to find the equation of the asymptote. So in this example, you can see that the equation of the asymptote contains the center, right? The center point, as well as the four corners of the rectangle. So we know that the equation of this line is going to contain the point A, B, right? Go over A and up B to get to this point. So what is the equation of that line? The equation of that line is y equals B over A times X. How do we get this? So if we look at the slope of the line containing the center point right here, which is the origin, and the point AB, we know the slope is rise over run. So we go up B units, that's B, and over A units, it's the run, it's A. So there are two asymptotes. One has a positive slope, the other has a negative slope. So that's the equation of the asymptotes if your transverse axis is horizontal. Your transverse axis is horizontal. Now if your transverse axis is vertical, it's just the opposite. So y equals plus or minus A over B times X. And of course if your center is displaced, then you're going to have a different equation. Okay, so for now we're just going to assume that the center is at the origin. So let's work a problem. Okay, let's work a problem. Okay, so let's just say you're given the following equation. Okay, you're given the following equation. Um, 9x squared minus 25y squared equals 225. Now the first step is to get it in standard form. So in order to get it into standard form, we have to get a 1 on this side, so we divide. And then when we simplify the fraction, we get the following. Okay? So now we have the equation of the hyperbola in standard form. So we're trying to graph this right here, that's the objective. We need to figure out what orientation the transverse axis is. The transverse axis is always going to be along the term that has the positive sign. So since this is positive, the x squared is positive, the transverse axis is along the x-axis. Okay, the transverse axis is along the x-axis. So we know from this equation that a squared equals 25, so a equals 5, and b squared equals 9, so b equals 3. Okay? So we know it's going to be this kind of a graph right here. So if we were to draw our axes, I'm getting better at this. Okay? We know that the vertices are going to lie along the x-axis. And we go over 5 units. We have 1, 2, 3, 4. So one vertex there. And another one there. Okay, so we have the vertices. Now we can form the central rectangle. Since b is 3, we go up 3 and we go down 3. So now we have the central rectangle formed. And we can draw the asymptotes. So the asymptotes are going to go along this line here, passing through the origin and diagonal. Again, passing through the other diagonal with a negative slope. So this one has a positive slope, and this one has a negative slope right here. This one right here has a negative slope. Okay, so where are the foci? So we have to use this equation here to find the foci. So in this case, we don't have to be precise, but the foci would be so c squared equals 34. So c equals the square root of 34, which is about 5 point something. We don't know. So we know the foci are going to lie along the transverse axis, right? The transverse axis is the x-axis. So we go a little bit more than 5. Okay. And then our point has to go through the vertices. Sorry, our graph of our hyperbola. It's going to look something like that. And like that. And lastly, the equations of the asymptotes. since we went up b and over a, up b and over a, the equation is y equals plus or minus 3/5 x. Okay, so that concludes our first problem using hyperbolas. I look forward to seeing you in the next video.